So the third way to solve a system of equations is to use the elimination method. The first thing you want to make sure of is that you have all your variables lined up, your equal sign lined up, your constant terms lined up, everything's lined up. If not, it's not going to work, or you'll get wrong answers. Then you're going to look for the coefficients of the same variable. So both x's, both y's, or whatever the variables are. They need to be the same, but the coefficients need to be opposite. So a positive 2 or a negative 2 and a negative 2. Those are opposites of each other. Same number, opposite signs. And if you don't find any, you can make some. Then you're going to add the equations, which is going to eliminate that variable, and we'll solve for the remaining one and then substitute for the other, just like we did with our substitution. So here's our first example. And when I look at this, I see that all my variables are lined up. X is on top of X, Y is on top of Y, equal signs are lined up, constant terms are lined up. Then I'm going to look for the coefficient of the same variable that's opposite. And what I notice is right here, I have a positive 8x and a negative 8x. So this is the same variable, the same number, but one is positive and one is negative. And the reason I want that is because if I add these equations together, 8x plus negative 8x is 0. It goes away. Negative 2y plus 6y is 4y. Remember doing this, that they have to be like terms. You could not add an x to a y. 18 plus negative 6 is 12. So now I have eliminated the x, and I can find out what my y value is. So y equals 3. Right here, I'm going to start my answer. So I have the y value of 3. Now I need to find the x. And I can find the x by substituting the 3 in for y in one of my top equations. It doesn't matter which one you pick. I'm just going to pick the first one because either will work. Again, I did 8x minus 2y equals 18, but instead of y, I'm substituting the 3. And I will solve this for x. So I have 8x. Negative 2 times 3 is minus 6. Add 6 over. 18 plus 6 is 24. Divide by 8 to get x equals 3. So my ordered pair, or my solution to this system for number 1, is 3, 3. For number 2, I'm checking and my variables are lined up, my equal sign, my constant terms, everything's lined up. And now I'm looking for variables that have the same but opposite coefficient. So for my x's, I have a negative 7 and 14, not the same. For my y's, I have a positive 2 and a negative 4, not the same. But what I am thinking is that if I multiply the 7 by 2, that turns into a negative 14, and that's what I need. So I will go ahead and do that. So 2 times negative 7 is negative 14. I'm just going to come below here. 2 times the 2 is 4y, positive 4y. And 2 times the 20, we have to multiply the entire equation, both sides, is positive 40. So now, if I take these two equations and add them, 14x plus negative 14x is 0. It's gone. Negative 4y plus 4y is also 0. It's gone. And negative 40 plus 40 is also 0. So don't panic. This is another one of those cases where we've lost all of our variables and we have to look at our numbers. Does 0 equal 0? Yes, it does, which means infinitely many solutions. Again, 0 equals 0 is not a solution. 0 is not a solution. You have to tell me that it's infinitely many solutions, and I would accept IMS as well. For number 3, I notice that my variables and everything is lined up, but I do not see the same, like a variable with an opposite coefficient or coefficients that would eliminate each other. So I need to see what I can multiply by. So I cannot multiply anything by 3 to get 10 and vice versa. I cannot multiply anything by 6 to get 10 and vice versa. So in this case, I'm going to have to multiply both equations. And it doesn't matter. I can multiply by 3 here and 10 here and to eliminate the x. I can multiply by 6 here and 10 here and eliminate the y. Doesn't matter. Because we haven't done one where we eliminate the y yet, I'm going to choose this one. So if I multiply by 6 here, 6 times 10 is a positive 60. And if I multiply by 10 here, 10 times negative 6 is a negative 60. So that's what I'm going to do. So 6 times negative 10x is negative 60x. 6 times 10y is positive 60y. And do not forget, we multiply the whole equation, which doesn't really change it much because we have 0. 10 times 3x is 30x. 10 times negative 6y is negative 60y. And 10 times the 0 is 0 again. So now we have a positive 60y and a negative 60y, and that's what we're looking for our elimination. So let's go ahead and add these together. Negative 60x plus 30x is negative 30x. Positive 60y plus negative 60y is eliminated. 0 plus 0 is 0. Next step will be to divide by negative 30. I have students kind of get panicky when they see the 0, but it's okay. 0 divided by negative 30 is 0. 0 is a number. It is a valid answer. So we have our ordered pair. We found our x value of 0. And now we can use that to look for our y value. So I can plug 0 in here or here to find my y. And it doesn't matter which one. They both work the same. So I'm going to do 10x, negative 10x. Whoops, not 10x. Negative 10 times x plus 10y equals 0. And I now know that x is 0. So negative 10 times 0 is 0. Which leaves me with this. Divide both sides by 10, and I get y equals 0. So here is my ordered pair for that one. For number 4, if I look, I see that I have my x's lined up, but my other things, they kind of look lined up, but my equals is in the wrong spot. So this is not going to work. But if I subtract my 8y over to this side of the equation, I then have everything lined up, I'm pretty sure. So let's see what this gives me. This gives me 4x minus 8y equals 16. And if I copy down the first equation, which is negative 4x plus 8y, equals negative 11. Now everything is lined up. All right, let's see. And I noticed right away I can eliminate my x's. So I'm going to go ahead and add my equations. 4x plus negative 4x is eliminated. Negative 8y plus 8y, that's actually also eliminated. So I have a 0 here. Equals 16 plus negative 11 is 5. So again, I don't have any variables, but it's not a situation to panic over. I have to look at what I have. 0 equals 5. That is not a true statement. And since that is not a true statement, that means there is no solution. That means there is no points that work on both of these lines. It also means if I graphed it, they never intersect, which means these two lines are parallel. And that's it. So here's a real world example for our elimination problems. You have $1.55 in nickels and dimes in a jar. You have 23 coins total. I need to borrow 10 nickels for a game that I want to play in class. So do you have enough to loan me the money? So if you have 23 coins, right? 23 nickels and dimes. You have the nickels and the dimes, and all together there's 23 of them. And if they equal $1.55, then the 5 cents per nickel and the 10 cents per dime should add up to equal $1.55. So we have two equations now that we can use to find out how many nickels you have. I wrote it so that everything is lined up, but I do not have some opposite coefficients. So what I'm planning on doing is I'm going to multiply everything by a negative 0.1 just because that's easy to me. I can do it in my head. If you want to use 0.05, you can do that. We'll get the same answer. So I'm going to multiply this top equation by everything by 0.1. So negative 0.1 times the n is negative 0.1 n. Negative 0.1 times the d is negative 0.1 d. And negative 0.1 times 23 is negative 2.3. So now I have what I wanted, a positive 0.1d and a negative 0.1d. So I know they will cancel or eliminate. And I can add my two equations together to solve. So 0.05n plus a negative 0.1 is going to be a negative 0.05n. 0.1 plus negative 0.1 we said is eliminated. And then I have 1.55 plus a negative 2.3. So that's going to give me a negative 0.75, negative 75 cents. So to finish, I'm going to divide both sides by negative 0.05. And I get, I forgot, 15. So Miss Keelan needed to borrow 10 nickels. You have 15 nickels. You have enough money. Yes, we have enough money or enough nickels to loan Ms. Keelan 10.